Hello everyone, welcome to Teach Easy Edu. Alright, today I have a question on physics, and the question goes like this. A rod is 1.58 meter long at 0 degrees centigrade. What must be the length of a brass at 0 degrees centigrade if the difference between the length of the two rods is to remain the same at all temperature? Linear expansivity of iron is 1.2 times 10 raised to the power of minus 5 per Kelvin, while linear expansivity of brass is 1.9 times 10 raised to the power of minus 5. Alright, we'll be trying to solve this and get our answer. Before then, pause the video and see if you can attempt the question. So let's go to the solution now. Now, we are having two materials, an iron rod and a brass rod. And the brass rod is having an initial length of 1.5. Initial length of 1.58 meters. At initial temperature of 0 degrees centigrade. Okay, now they now say if the difference between the lengths of the two rods it remains the same at all temperature, that is to say the difference between L2 minus L1. L2 is the final temperature, while L1 is the initial temperature. Alright, so this L2 minus L1, which is the difference, is the same for both the rod and the brass. So what we are going to do now here is, looking at this question, we would observe that this is a linear expansivity problem. So we are going to look for the linear expansivity of the iron rod, then pick their differences and look and see how we can find that of the brass. So for the iron rod, linear expansivity, which is represented by alpha, is equals to L2 minus L1 over L1 open bracket theta 2 minus theta 1. And from our question, our linear expansivity is given as, for iron, is given as 1.2 times 10 raised to the power of minus 5, which is equal to, now since we are looking, since they gave us the differences, they asked us that the differences from the question says the differences between the two lengths is the same for both materials. I'm going to leave this as this, L2 minus L1 over, now we know that the L1 for the iron rod is 1.58 open bracket. We are going to assume, since is so we are going to assume that our theta 2 is equals to 100 degrees centigrade. The reason why we are assuming that is, from the question they said the differences between the lengths of the two rods remains the same at all temperature. So there was no specified temperature. So 100 minus 0, 1.2 times 10 raised to the power of minus 5 is equals to L subscript 2 minus L subscript 1, which is the final and initial temperature, length rather, over, when we do our subtraction here, it's going to give us 100. 0 minus 100 will give us 100. 1.58 times 100 would give us 158. Then what we do here, we cross multiply. L final length minus initial length times 1 will still give us L2 minus L1, which is equals to 158 times 1.2 times 10 raised to the power of minus 5 would give us 0.001896. Now we are having the differences in the two lengths as 0.001896. Now we can use the difference now to calculate for the initial length of the brass rod at 0 degrees centigrade. In doing so, let me move this to this side and draw my line. In doing so, the initial length for the brass, the initial length of the brass rod was not given, L1. So but the linear expansivity of brass was given as 1.9 times 10 to the power of minus 5. So following the same formula for linear expansivity, L2 minus L1 over L1 open bracket theta 2 minus theta 1. Here we are also going to assume that theta 2 is equals to 100 degrees. So since now, the reason why we also had assuming this is because at all temperature they are the same. So since we are using 100 degrees centigrade here, we'll also be using 100 degrees centigrade here. So our linear expansivity for brass is 1.9 times 10 raised to the power of minus 5 equals to the difference in length now becomes the difference in length we obtained from our iron. The difference in length are the same. So L2 minus L1 from our iron material is 0.001896. So what we do, we input it here as 0.001896 over the L1 is unknown, 100 minus 0 degrees. So now we have 1.9 times 10 raised to the power of minus 5 equals to 0.001896 over 100 minus 0 will give us 100. 100 times L subscript 1 will give us 100 L subscript 1. So we'll cross multiply. 1.9 times 10 raised to the power of minus 5 times 100 would give us 0.0019 L subscript 1 equals to 0.001896. Now we divide both sides by the coefficient of L subscript 1, which is over 0.0019, divide by, also dividing the right side by 0.0019. So this, we cancel this. L1 is equals to 0.001896 divided by 0.0019. We would obtain 0.998 meters, and this is approximately 1.0 meters. Now we can verify if the differences in the two lengths of the materials are the same. Okay, I will leave that as an assignment for you guys to try, and when you do so, you can comment on the comment section and tell me what your answer is. For more videos, kindly subscribe to our channel. Thank you very much for staying tuned. Bye.